We are now entering chapter 4 of our Pearson textbook. We're finally going to start to think about algebra as functions, that everything we're doing has a purpose. There are things that we are inputting into equations, which are technically functions, if they meet certain parameters, which we'll find out in this chapter. And we have to think of this as a growth in math. We're no longer just doing things aimlessly. We're doing things with a purpose and for a reason. And it's to evaluate something and give a possible representation of what maybe all possible answers look like for a given equation or a given function. So let's start looking at this. We're going to be starting off by showing and using graphs to relate two separate quantities. So you're going to notice that in this particular chapter, we're going to start to see more than one variable in the exact same problem, so that we will learn to relate equations to solving for different variables. What happens if we use two variables? What do those variables represent? This all has to do with sometimes graphing when we represent it visually or computationally, and all kinds of cool things. So this is a key point right here. When you have two variables, there is a relationship that's happening between them. Just like you have like a relationship in your house, like you're the kid and you have parents, and like, you know, what you do in the household helps the overall outcome of the house. Like, hey, you're helping watch your brothers or sisters so that your mom or dad can work some overtime to make more money for a family. All those things, those are relationships. And it's the same thing that happens in these equations, okay? You'll see that X and Y are related to them. Certain things have certain meanings. For each X that is inputted into an equation, you get a value of Y. So the X's are our inputs. They are the independent variable. It doesn't matter what they are. You can plug anything in for X. Depending on what you plug in for X will determine what you get out for Y. First thing we have to make sure that we're able to do with equations is that we like them set equal to Y. So like Y equals, so that we can see how that looks like, because our goal is we're trying to solve for Y. We want to know what Y is, but they don't always give it to us like that. What they did here is they gave us this equation in example 1. They gave this to us in a standard form, meaning that all of the variables are on the left-hand side of the equal sign and the constant is on the right. What we generally want to do is we want to solve for Y. So again, this takes into account some of that solving like for literal equations. Our goal is to solve for Y. Y is trapped on this side. So if we have our scale, right, what we do to one side, we have to do to the other. Well, I don't want this 6x here. So how do I get rid of a positive 6x? Well, I do the opposite. I subtract 6x. Notice that's what's left. These will cancel. I have a 2y equals. These are not like terms. We cannot add them. We simply bring them down. Now, y is still not by itself. So what do we need to do now? We need to make sure that we go in here and we are going to divide by 2, because division undoes the multiplication. If I divide one piece by 2, every term on the other side has to be divided by 2. That is the division property of equality. So now we have y is equal to, well, negative 6 divided by 2 is a negative 3x. And 2 divided by 2 is 1. And like that, we've taken an equation that was written in a standard form. Again, this here is standard form. taken an equation written in standard form and transformed it into this fantastic little form here, which we'll learn later on more about this particular form, which is our absolute favorite equation in algebra. Sometimes you need to test some examples, okay, so that we can be able to put points on a graph to visually see what these like functions represent. This is an equation. An equation is also known as a function, provided that it passes certain specifications. For today, what we're using, these are definitely functions. I'm telling you they're a function, so we know they are. We need to create some values. What is the result, or what are the results of this particular equation? Well, you have to graph it, guys. We represent these x's and y's as ordered pairs. For each unique x that we plug in, we get a unique result. So let's look at this. If I plug in 1 into this equation here, I'm going to plug in a 1. I'll plug in 2. I'll plug in 0. Okay, so let's plug in 1 into this, and you have to evaluate it. Right, -3, we want to remove the x and plug in a 1. Notice I wrap it in parentheses. When you substitute something into an equation, you remove the variable, you put a set of parentheses in there, and you plug it in. And I'm going to change this here. Watch, I'm going to change this to a negative so we can see why, right, as we evaluate these. Okay, so let's start to evaluate this first one. We're evaluating x for 1. So 1 times -3 is a -3 plus 1. -3 plus 1, you owe somebody $3, you pay them back 1, you still owe them 2. So in this particular equation, in this particular function, we plugged in a 1 for x, we got out a 2, -2. Now we're going to do it again. -3. We remove the x with a set of parentheses, and this is why it's important to put the parentheses. We're going to plug in a -2. Okay, if we would have plugged this in without the parentheses, it looks as if we're subtracting 2, but we're not. So we have to make sure we're using the sets of parentheses, guys. Now let's evaluate it. Well, -2 times -3 is a +6. 6 plus 1 is 7. Now we're going to plug in a 0. Well, -3 times 0 plus 1. Well, -3 times 0 is 0, and 0 plus 1 equals 1. So right like that, guys, think of it like this. Look, we have what? 3 sets of ordered pairs, x's and y's, that can be put onto a graph. And we could actually graph this if we wanted to. Of course, this is just a brief sketch. We have the point 1, -2. So 1, -2, so dot. We have the point -2, 7, so -2, 7. Right about there. And 0, 1. Notice how all these lines just happen to line up. Of course, if I draw my line a little straighter. But every single point that could possibly fall on that line is technically a solution to this equation or this function here. You can put multiple coordinates on the graph, and as you keep plotting more and more and more points, you'll see this relationship between the independent variable, the x, the number that you're plugging into the equation, and its output, the result. Together, they form this line. Each ordered pair, as you plot them, keeps forming on the line, keeps forming on the line, keeps forming on the line. So not only do these variables have just like this numerical relationship going on, most of the time these equations have some sort of actual real life meaning. So let's look at this graph that we have here. We have what? We have grades. Your y-axis is representing grades, and your x-axis is representing time. So let's see this. If at the beginning of a class period, right, the beginning like the second 9 weeks, every student starts with 100. And as you start to complete assignments, well, as you don't do things or you miss questions, your grade slowly starts to go down. So here's like week 1, it's down. Week 2, it's down a little farther. Week 3, it's really started to go down. It's at its lowest. And then what happens about halfway through 9 weeks? Progress reports come out. So then what do you guys do as students? You start trying to improve your grade. And so what happens? Oh, look, the grades start coming back right about this halfway mark. Then you slack off again and your grades start to drop. And then you get about 2 weeks before the end of the 9 weeks and you're like, uh-oh, I need to bring my grade back up before report cards come out. And here you go, up goes the grade again. So you can kind of look at this graph. You're like, well, what is the average? What is your grade at about 5 weeks? Okay, so weeks is the X, that's the input at 5. You go straight up the line to here, and then you look, well, what is it when you draw it back to the y-axis? Oh, so you're almost to B. You're probably about 78% or so when you're at week 5. What about week 3? When, let's say maybe we're evaluating this function for when x equals 3. I'm going to write another, here's maybe a function notation too. When the function f of x equals 3, meaning the x is equal to 3. That's what this means. When we see this fancy function notation, what is the function f of x? It just means what is it when x equals 3? So again, you look on your x, because this is what we're dealing with, x-axis, you look at 3, go straight up till you hit the graph, and then go straight to the y-axis. Oh, look at that. They let whoever this is, if you're tracking their grade, they let their grade fall to about, I'd say about a 50. So when x equals 3, we sit over here, when x equals 3, your y will equal 50. Or for the function f of x, they're looking for f of 3, meaning your x is equal to 3. The solution would be 50, because that's the ordered pair. That would be if you were to plot this dot on the graph, that's the coordinate 3, 50. Being able to like graph these real world situations makes a lot of sense here. Let's take a look at this. Here is we're going to say this graph here represents this delightful little bird. Here's this little bird. And he has a stick. Right? And here he is. He's flying at about 900 feet. And he drops the stick. And as time progresses, and we'll say this is seconds, right? So we'll say 1, 2, 3, and so on, right? 5, 6, 7, 8, 9, 10. So he drops this stick and it takes, this is the path that the stick is falling. So it's falling at this rate. And in 10 seconds, it goes from 900 feet down to 0. Okay, again, if this is the function, so we'll say they want to know what is f of 2. So this graph represents the function. Here's the graph of f of x. F of x. And that again equals y. So here is this graph f of x. Okay, it represents this equation. We're trying to find what is the y when our x is 2. So you look over here on the x-axis, 2, and you'll come straight up. Best you can. I'm clicking with a mouse. And it looks like they're probably at about, if you come back this way, after 2 seconds, what is that? About 800, approximately 850 feet. And if they say, well, what is f of 5? As you go 1, 2, 3, 4, here's 5, right? We're gonna try to do our best to go straight up to the line. And we'll go straight over. That would be approximately 700. That's how we evaluate or solve an equation from a graph. They tell us they want an x, and so we go to the x-axis, we go straight up to the line, and then we go right back to the y-axis to see where does it line up. They could also reverse it on us. What if they said, if f of x equals 400, right? So f of x is equal to y. So now you look at the y-axis at 400, and you're going to reverse this. You're going to go this way to the x-axis. From the y-axis straight to the graph, and then you're going to go straight down. So I say that's what, 5, 6, 7, about 7.5. So in this case, x would equal about 7.5 because we're falling from 400 straight to the graph and then straight down. So you're looking about 7.5. Not so bad. And again, here we go. Again, they're talking, instead of writing it as y equals 20 plus 20x, they're using function notation. So we have to get used to start seeing this. This is just a fancy way to write a whole lot of information without us having to actually do it. It says, here's the equation, f of x, where x is the independent variable. X is the variable that you see inside of here, right? And for whatever value of x, that means you're going to take this number and substitute it for x. So they want us to graph a couple of these and see what happens. X numbers to cut the lawn for a graph. So we're gonna graph this and just see what's going to happen here. So here's the situation. If you don't cut the lawn at all, 0 cuts. Okay, so we have what? 20 plus 20 times 0. Right? Well, these will turn to 0 and you're left with 20. So when x is 0, your y is 20. So 5, 10, 15, 20. I'll say there's 1 point. And we'll do 1 cut. Let's try this one. Okay, so 20 plus 20. All right, so what? 1 times 20 is 20. 20 plus 20 is 40. I'm actually going to change this legend over here because I needed it to be bigger. I'm actually going to go by 20s. 20, 40, 60, 80. This is like the price to cut your lawn. 1 cut, 2 cuts, 3 cuts. All right, and then we're going to do the last one. So 20 plus 20 times 2. So what are we doing? We're going to, for this function, when x is 2, we're going to replace this x with the 2. 2 times 20 is 40. And 40 plus 20 equals 60. So when x is 2, your y is 60. Again, it's an ordered pair, so you can go, let's graph these so we see it. Here's our 20. So you have this lawn service, right? If they don't cut your grass at all, they're charging you $20 as a service fee, and then $20 for every cut. All right, so if you don't have your lawn cut at all, they're still charging you $20. If you have your yard cut one time, well, that'd be 20 plus 20 is 40. If you had your yard cut twice, it's a base charge of 20, and then 2 charges of 20, 2 comma 60. So you can see, look, this again, this here forms a line. And away we go. That's the basis of this, guys. So again, we're rolling this up and we're realizing that as we look at these, we have equations with 2 different variables. We can use different values to plug in for the x, the independent, the input, and then, you know, it's always easier for us to solve it when it's already solved for y. And sometimes they like to get fancy on us and say, instead of calling it y, they'll call it f of x, which just is a fancy way of saying, hey, here's this equation, and the variable is an x, the independent variable is x, and they might throw a number at us to say evaluate it. We can evaluate any equation or any function by listing a bunch of x's and simply solving it over and over again. These individual little ordered pairs are points on a graph, and when we make a graph, that graph is literally a cheat sheet of all the possible answers. All right, so think about this, wrap your minds around it, start to do the homework and practice, and you'll notice that as we go through this chapter, you're going to learn a whole lot and realize how a lot of this different math we've been doing all starts to connect and intertwine with each other. All right, get out there, guys, do your homework, and have a great day.